Okay, so this is section 3B. We're going to predict the stable ions that form, and we're going to write the ionic formula. So this is kind of a continuation at the end of section 3. So as a review, recall that calcium becomes stable having a +2 charge, and oxygen becomes stable by getting a -2 charge. So that would be predicting the stable ions that form. To write the ratio, we have to look at how many electrons is calcium going to give away, how many electrons does oxygen need to receive, and how many of each element does it take for everyone to accomplish an octet. In this case, it was a 1-to-1 ratio because calcium giving away 2 electrons to oxygen accepting 2 electrons. I only need 1 of each, 1 calcium, 1 oxygen. So the ionic formula is CaO, 1 calcium, 1 oxygen. We ended the last video with sodium and nitrogen, which would form an Na+1 and an N-3 as their stable ions. And then as we looked at the transfer of electrons, it took 3 sodium atoms to 1 nitrogen atom in order for all atoms to have an octet. And so we have a ratio of 3-to-1, 3 sodium to 1 nitrogen, and that made us our ionic formula. If you'll notice, there's kind of a trick here in that the sodium has a +1 charge, and I only needed 1 nitrogen, and the nitrogen has a -3 charge, and notice it took 3 sodiums. So there's a little trick here. If you'll notice, the charges tell you how many of the other element you need. So let's look at one more example. To predict the stable ions, first I have 3 valence on aluminum, which will give me an Al+3, and then there are 6 valence on sulfur, which gives me an S-2. So these are my stable ions that will form. So now I need to predict, not predict, I want to determine or write the ionic formula. So aluminum has 3 valence, 1, 2, 3, and sulfur has 6 valence, 1, 2, 3, 4, 5, 6. If we analyze the transferring of our electrons, we're going to see that aluminum is going to transfer this electron here. This electron is going to go here, and now this sulfur has a charge of -2, and it has an octet. But aluminum still has 1 more electron to give away, so it's going to give it away to another sulfur, which has 6 valence. Dots. Okay, so now aluminum can get rid of its last valence there, giving aluminum a +3 charge and an octet. But now my other sulfur is not quite finished yet. It still needs another 2 electrons. So I need another aluminum, which has 3 valence electrons. So notice that this aluminum is going to give away 1 more to here, giving my sulfur a -2 charge and its octet. Forgive the color inconsistency. There we go. So now that sulfur is good, except I still have 2 more electrons to give away on my aluminum on the left. So what we'll need is 1 more sulfur with 6 valence electrons. And now aluminum can give away its last 2 electrons, giving this sulfur a charge of -2, giving this aluminum a charge of +3, and now we're done. So what's our ratio? We have 2 aluminum atoms to 3 sulfur atoms. So it's a ratio of 2 to 3. So it's going to be aluminum, 2 of them, sulfur, 3 of them. This will be my ionic formula. And let's look at our little trick from before. Remember, aluminum is a +3 charge, so it's letting me know that I need 3 sulfurs, and the sulfur was a -2 charge, letting me know that I was going to need 2 aluminums. So we kind of like to call this the flip-flop method, or the switch method. So let's look at our shortcuts. There's two scenarios. You either get a 1-to-1 ratio where the charges will cancel. So for example, if I had Na with a +1 and Br with a -1, then I need a 1-to-1 ratio because the charges will cancel. And so that gives me NaBr as my formula. Another example is if I had Al +3 and P -3, then the charges are going to cancel each other. +3 and -3 cancel, and I need just one of each, a 1-to-1 ratio. So this is a 1-to-1 ratio scenario. If you have +1, -1, +2, -2, or +3, -3, they cancel, and we have a 1-to-1 ratio. The second trick is going to be if the charges must be switched to get the ratio. And that example would be like calcium, which is +2, and fluorine, which is -1. And so this +2 lets me know that I need 2 fluorines. This -1 lets me know that I only need 1 calcium, but we don't write 1, it's understood. So my ratio is 1-to-2, which means I need CaF2 is my ionic formula. Another example would be if I had, let's see, calcium, let's try to use something different than calcium. How about barium +2 and nitrogen, which is -3. Notice again, our charges are going to tell us our ratios. I have a 3-to-2 ratio, so I need Ba3N2 for my ionic formula. And this is called the switching method, or the flip-flop method. So let's practice writing these ionic formulas. If you'd like to pause the video now, you can try to write all the answers, and then you can unpause it in order to see what they are, what the correct answers are supposed to be. Here I have aluminum +3, chlorine, which is -1, so that's going to give me AlCl3. Calcium, again, is +2, oxygen -2, so we cancel, and that's a 1-to-1 ratio, CaO. Lithium is a +1, nitrogen is a -3, so they switch. It's going to be 3 lithiums and 1 nitrogen. Magnesium is a +2, bromine is a -1. These are going to switch, giving me MgBr2. Barium is +2, phosphorus is -3, so we switch charges, giving me Ba3P2. Beryllium is +2, fluorine is -1, and if we switch them, we get BeF2. Potassium is +1, sulfur is -2, so I'll switch those and I get K2S. And lastly, aluminum is +3, sulfur is -2. If I switch them, I get Al2S3.